So the last session we spent about talking about networking. In fact, the last 2 sessions, so an entire week dedicated to networking. And I mentioned before, yeah, I needed in cloud, therefore we did it. But I hope you guys, the ones that were here anyway, but also if you watch it on the stream and so on, kind of could retrace what the networking elements are about, because we still, even though we don't need to do it on a daily, need to use it on a daily basis, especially not if you're a programmer, but you will still need to understand a lot of it when you want to debug your applications, for example, either using Wireshark or other tools, like there's, what's the other tool, Fiddler, right? So there's, it's used to inspect HTTP service requests, or the web development tools from your browsers and so on. But we not only need this for the actual development of programs, you know, like your REST environment and so on, but we also need it for, you know, configuring richer, you know, cloud services, especially when we're talking about infrastructure as a service. So far, has anyone talked to you about infrastructure as a service and the other as a service concepts? How many of those do we have? Yeah, but there was something?
You mean like SaaS,
yep.
as a service?
Yeah.
IaaS, infrastructure as a service?
Yeah.
Platform as a service?
So, yep. Anything else?
Yeah. Any more?
Okay, that should do, right? So there's, in the meantime, there's a bit of a hype around as a service. So you have kind of a star as a service, so everything as a service, kind of. We'll see how far that goes. But in the context of cloud computing, you're right, it's those 3 ones. What's the difference between them? They're not necessarily you, anyone, really. So we don't. But you can, of course, if you feel.
Software as a service, which is more like that the software runs on the, like we have in Gmail. Would be something as software as a service.
Yeah.
Because they run most of the software on their servers.
Yeah.
Try to come up with 2 examples for the others.
Yeah. Okay. Who wants? Let's branch out. So that was a good one. So Gmail is a classical example. Any of those online services that you use, basically, right? They will consider software as a service because you're basically using a universal client to interact with them, usually the browser, I guess. And for example, what's another example for software as a service that you perhaps know?
I suppose the assignment we're working on would be a software as a service.
What?
The IGC service we're working on.
Yeah.
Would serve as a software as a service.
It will be one, yes. But you as a user now, what is another popular example for software as a service? But you're right. You're right. We get to that. We come back to that link. That's a good idea. One of the more popular ones is this Office 365 for Microsoft. They put everything online and remove the client-side things, you know, so you can basically do it online, use Word, Excel, PowerPoint, and so on online. That's one of the more famous examples of software as a service, but not the only one. Okay, platform as a service. One example you should kind of have handy, at least. Anyone? Yep, exactly, right? So it kind of has a bit more, yeah, a bit more infrastructural feel, right? So you need to put something on top of it in order to make it useful, right? Otherwise, Heroku by itself is not really, you know, useful at all, right? So it needs to be used by developers to create something like you said, like a software as a service on top of it, right? So it sits a bit lower, right? That's right. So. And the last bit then is, of course, infrastructure as a service, right? So the lowest one. So if we have something like Heroku, why would we use anything that has more infrastructure to it on top of it?
We might want to care about which kind of machine is running the software, which we don't control or don't really care about using App Engine or Heroku.
Yeah.
Using OpenStack, we can choose what kind of server we're running.
So it's really about more control, right? So that's a very good point. So you can actually figure out, okay, I need a lot of RAM, but very, you know, only 1 or 2 CPUs because there's not much multi-threading going on. So then I can actually customize my environment. In Heroku, you're subject to their scheduling policy, right? So whatever you upload, they will ultimately execute it. What can be another factor?
I might want to limit myself to an operating system.
Nice.
If I'm using infrastructure as a service, I'm most likely an admin kind of person that use a lot of different kinds of software. I might want to specialize myself in Linux, for example, using the software and the techniques that are available there. So,
yeah. So exactly, you have control basically across the entire software stack, right? So it's not only the hardware that you, as you mentioned, which is good, but also software on top of it. Which operating system do you run, right? Which operating system does Heroku run? Well, we don't need to care because we can't change it anyway, right? So we kind of buy into their API, and that's roughly it. That's right. So those are the general, some of the general concerns. And one way of putting it in a way is that you have kind of a software stack that starts at the bottom with storage, processing, and network, right? The core functionality that's provided by by the hardware eventually, right? So any operating system needs to support those 3 capabilities. So then you basically have computing power, and then you build, there are some services running on top of it, right? So for example, like a web server in the simplest sense, or DNS services and so on, that allows applications to run on top of it. So if you think about it like a stack, you can look at the models in this very way, that in the case of PaaS, you basically provide the operating system plus framework. I mean, it's a very blurry boundary there. But you guys then are in the position to actually provide and write the services that are running on something like Heroku, right? In this case, the IGC service, for example, right? So the classical IaaS example, whereas PaaS example, sorry. Whereas in the infrastructure as a service, it's really about you getting virtualized hardware eventually, right? So, and you kind of need to figure out and put it to use and run an operating system in there. So you inherit all the responsibilities that, as you mentioned there, a network admin has, or system admin rather, has as well. But of course, you also need to have networking knowledge. That's why in this course we're talking about networking as well, at least touching on the intro, because otherwise you won't even be able to configure your own IaaS service in the first place, right? So it's really on the kind of need to know basis, but you kind of need to have an understanding of it in the first place. And so those are the key 3 models, and the idea is that in this course we work across all of those ones, right? Mostly on the PaaS and IaaS level, because the SaaS level is mostly about using existing APIs as they are, but not really thinking about hosting them, which you do of course as well. So, but you should be able to differentiate when am I using what kind of approach when I'm providing software in particular, or which approach is useful in which context. But all of you will have not only opportunity but the necessity to interact with all 3 types of mechanisms, so you have a good practical understanding at least of what's part of it. So there's this cloud taxonomy, which is kind of a bit dated, this thing, but it's kind of a good way of structuring an overview of the different cloud services that are, or as a service mechanisms that are available, and trying to categorize them somewhat by characteristics. And it's I put the slide set out there, of course, but there's a set of particular products that would actually satisfy those requirements, right? So in the infrastructure area on the top left, we have storage, computing, and service management, if you like, and they're all centered around running some sort of infrastructure. So they have Amazon S3, Google Bigtable, and so on. It's about data storage. Then Amazon EC2, which is their computing solution. So Amazon Web Services basically consists of a large range of different products or components, if you like, that have different purposes. Something we're not talking about today, but later on, because it's like the next, the biggest IaaS system that's currently available. But here it's more about taking the components apart and associating them with particular functionality. Service management, then we have cloud software, which only focuses on the functional level. For example, it's about providing efficient data reduction mechanisms or data management. For example, MongoDB, if hosted online, is considered a cloud software in this sense. And then there's more ready-made platform services that look at organizations as customers, where you can basically subscribe. For example, I think Salesforce is one of those where you basically can outsource your entire business operation or the reporting on the business operation to those ones. That kind of sit in between different departments and roles, and then of course the usual software services, which are basically just end products like Google Apps, Zoho, Office 365, and so on. But I don't know. So it's a bit of a way of structuring what kind of aspects we're dealing with in those different categories: infrastructure, platform, and software. Here highlighted. So now, thinking about the differences, not so much between SaaS and IaaS, but rather it's platform as a service and IaaS. What is decision-making determinants when you think about going either PaaS or going IaaS? So you mentioned some there, but let's explore that a bit so they get a more explicit understanding. What would be your decision-making of, why do you use Heroku, for example?
I would use Heroku if I did not care at all about what is running my software. I just need that my software is being run.
Yeah.
If I would use IaaS, I would probably be running several services at once. Again, it's mostly the admin kind of choice. If you want to run basic Apache servers like load balancing and a database, then you want to have control over it all, and the choice in which vendor to use, like Mongo versus SQL, etc.
Yeah.
Then you would use IaaS because you have that. You're basically given a platform in which you can make or destroy VMs.
Yeah.
If you want that to design like an infrastructure kind of thing, you want to use that. And if you want to just have a program or many programs, software that run no matter what, you would use App Engine or Heroku.
Yeah. Cool. I like your response in a way that you're just saying, okay, I just want to run something, right? So put it up there. I'm done with this. I don't need to worry about it too much anymore. Thinking about the production side, you mentioned, okay, if I want to really get an understanding or want to specify myself what software is running on and the underlying basis and kind of optimize it for production, then it's probably better to go a bit down IaaS route. So that's good points. But what is another technological cost of using PaaS services? If I use that term, not sure if it. Another aspect. If you're thinking about, did any one of you use Heroku and Google's alternative? Yeah? So what was your experience?
I didn't have much experience with the App Engine. I just put it up, so I couldn't really give a fair comparison.
Yeah, but in terms of development, did it affect you?
Well, the Google App Engine kind of helped me develop a lot in the browser, but I don't think that was just a feature I used. I didn't think I could compare them fairly.
Okay. So you basically run the same system on both without much modification?
It was just a different setting up, and after that it was kind of similar.
Okay.
Are you thinking more, are you looking for, like, if you use one specific system, you would have to learn that system to use it productively and advanced, and so you would end up kind of vendor locked? So if you choose Heroku and get really, really good at Heroku and use all the advanced features that it offers, it would be very hard to move over to, for example, App Engine. Whereas if you run your own infrastructure, you would know that you would be able to control that, and so you would have a lot more, choices in what kind of service you want to run.
Yeah. So that's precisely. Did everyone hear that? Yeah, oh, you guys here as well, right? In comments. Because that's a very good point. You have a vendor login, that's technological cost, right? So once you really become good at using Heroku, not only uploading and running your Go client, but actually using their timer services, their scalability service, their load balancing, which they have as well, of course at a cost. So then you become really, really good and get your production system very efficiently running. but you're kind of locked in. You will be a customer with Heroku for considerable time until you really scrap your software and start redeveloping, which is oftentimes not an option once you're actually in production, right? Because how much time do you want to spend on redeveloping your product as opposed to optimizing it or creating version 2.0, right? So that's a very good point.
Yeah, that's why I swapped from the App Engine, because everyone else was using Heroku.
So there's already an effect, right? Because you could benefit from a social, support from support from others because they're specialized in something else than you were already, right? So there you see, that's a practical example of why you shifted, right? You kind of paid those technological costs and say, okay, I'm investing my learning time in something else because I will be faster in the long term, as in terms of cost. But either way, so that's precisely the point I would like you guys to internalize, right? So it's really about, if you pick such a platform for doing some quick prototyping, it's really good, right? So getting something out there, running it very quickly and just showing something. Question is, if you really want to put it in production, do you really want to buy any additional features? Because it will happen. Suddenly you need to have some cron services, an additional functionality, or that is not really provided out of the box, and then you end quickly on the paid tier, which is not the worst thing. But you also suffer from vendor login, because if they change their price model, yeah, kind of yours changes as well, right? So you're kind of tied down to some extent unless you want to really do some development. So it's a bit of a challenge there. But in general, of course, there's the idea in PaaS, you really focus on the application. You don't get confused with focusing on, networking, operating system, all that stuff in the application development, or even the deployment is super easy, or reasonably easy anyway, in PaaS service, because they're specialized on that. And it's kind of oftentimes easily integrated into their tool chain, not necessarily your tool chain. And that were the challenges that we just highlighted there. So, and quite, the flip of the coin, the mirroring aspects are basically IaaS. You have in reality, the boundary between PaaS and IaaS is actually not that clear cut. Because if you look at most IaaS vendors, they actually also have platform as a service products on top of it, right? So it's usually a superset of PaaS, plus infrastructure. So basically, that's the idea. Because you'll find deployment mechanisms similar to Heroku for Amazon as well, right? As part of your Amazon account, one of the many services. You'll get an overview on that later. So that's in a way it's good. So you can still use platform as a service offers in an IaaS situation, but it also allows you to have full access to the raw resources, if you like. If you want to have processing power, if you want to have RAM, how much storage you need, networking, connectivity, load balancing, and so on. You can basically run a full virtual data center at your fingertips. As long as you pay, of course, right? So there are certain limits there, but you literally have access to a large amounts of RAM that would be unimaginable on your own machine, right? So simply because of the idea that if you pool resources, which Amazon and others can, it's a lot easier and cheaper to provide them ad hoc. But of course, some of the intricacies of running this, we explore that a bit later. So you're kind of flexible in terms of your implementation language. So you're not tied down to not only the particular deployment API of Heroku or the like, but also programming languages. If you don't find a binding for a supported language in Heroku, yeah, you kind of have a problem, right? So you're tied down. But here you can set up your own environment and can use any unorthodox approach that you like. Or, for example, PaaS cases sometimes that you tied down to particular version of dependencies provided by the operating system. And this is, of course, a flexibility you have. What is the burden of IaaS? Oh, there's a comment, please.
Yes, I was just thinking about when we have like Heroku, for example, we would have load balancing, we would have storage and stuff like that. Often these products would be kind of one size fits all. And so if I happen to have a software or something that's very reliant on, for example, load balancing, which is clever load balancing. If I know a program or have developed a program that can do it much better than Heroku, I would probably much be probably want to run it myself through an IaaS instead of using Heroku. And so I kind of guess using a platform as a service would be good if you have a company consisting of almost only developers. The initial cost would be low.
Yeah.
So you can just start and make some money and work on it as you grow. But if you have one admin or a couple of admin people on the team, you would probably want to use an infrastructure, putting more cost at the beginning, but then you've locked it there, and so there will be more stability and less cost as you go. You will be able to expand without as much cost as you would with for example, Heroku and Apple.
Yeah. So that's exactly a brilliant point, right? If you plan to grow or you don't know how you will grow, that's the clear answer there. With Heroku, eventually you probably need to make the cut and say, okay, now we redevelop from scratch, or at least port it to an IaaS solution and then set it up again. But there's a lot of technological cost at that time, right? In the somewhat mid-term future. So, but if you invest immediately into IaaS, you avoid all that at an expense, of course, right? Twofold. Number one, oftentimes payments, which may or may not be the case, because depending on the load, IaaS may actually be cheaper. But of course, in terms of people generally, right? Competence, you need to have some sort of background to manage that. But part of the idea of those cloud services is also to lower the threshold of you intervening actively in an operating system, right? So there are a lot of mechanisms that help automate setting up. For example, you're not supposed to install an operating system anymore, right? That's not going to happen. You're getting a ready-made image, that's stock image, and you can just start to configure it, either using tools such as Puppet and the like software configuration management tools. The networkers amongst you will know those. Yes, no, perhaps? Yeah, things like that, right? So that you use or of course solutions such as Docker that allow you to deploy, for example, your Go services on those, something we'll talk about as well. And you'll see the boundaries between system administrator, network administrator, and programmer are actually kind of really murky, right? So because you can suddenly program the deployment, and that's kind of this DevOps movement where it's actually more fluent, the interaction between both sides. So it's not as clear cut that you need one dedicated admin anymore, but you need to be able to script or program against the APIs provided by Amazon or the like to spin up something. And that's something a programmer is very comfortable with generally, not only the admin per se. But of course, you need to have some sort of competence in case you need to have a quick intervention or the like, right? So, or for security assessment and so on. That's a valuable point. But something you of course need to also need to do if you're running actually your own infrastructure, you kind of need to keep it up to date, right? So because the responsibility is up to you. It may not be hard, but you still need to run the updates of your operating system and so on, right? So all that stuff is done for you if you use the platform as a service solution, because you can't touch the operating system, right? So that's good in a way. So apart from all that tech talk and those ideas, is there any other reason why you probably should know about IaaS? Apart from your knowledge, the skill set, investments in terms of company growing, especially when startups involved. But what other aspects are probably decisive to make you decide whether you want to buy into a PaaS platform or IaaS platform? And I'm talking to you in particular as students right now, not so much as startups, entrepreneurs or the like. Always looking in this direction. I'm hopefully not missing anyone there.
Well, there are a lot of old companies.
Yeah.
That's a fact of life. Companies are old, many of them, and a lot of them will have had to run machines on their own, and so. It would often be good for us to know that, okay, we get to like our first job is probably low end, and we see that they have a ton of servers just standing there doing nothing, just one old guy.
Yeah. With a white beard, right? So that old Unix guy that sits in the corner no one talks to, right? Yeah.
You see him during the Christmas party.
Right.
He lives in the basement.
Right.
I want to be that guy. But, and so it would probably be a good thing to know, at least know about IaaS, so
yep.
You can suggest that maybe we should put this on like an IaaS platform,
Yep.
because with that we can scale up and down as
Yeah.
needed, spinning down and spinning up VMs as needed, and as ready from images. We don't have to reinstall anything. You can just take a screenshot or a snapshot
Yep.
of a VM that works,
Yep.
and just put it up.
Put
if
it
you
up.
need it, take it down.
Yep.
If you don't need it.
Cool. Yeah, then that's
So we can save a lot of financial costs just in not having hardware lying around that's not being used.
yeah, that's right. Just expanding. You have a comment?
Well, it's not a comment to what he said, but what we also could consider is what kind of data we're treating and storing.
Yeah.
In the service.
Okay.
If
Yep.
we have personal sensitive data, we should not transfer it to someone. that we
Very
trust.
good. Very good. Yep. So that's a good point. We come back to that one in a second. Just coming back to your comment, which is really good. So one of the key drivers for cloud services is exactly what you say. It's the conversion, and just the conversion of legacy systems. Right? It's not really active development. It just means, oh, a server is dying. What do we do? Well, let's put it in the cloud, so we don't need to buy a new server. Right? Because hardware usually lasts how long? What is the average? How long does it take for hardware to be written off?
I'm not sure, but
Accounting-wise?
3 years?
3 years is the usual write-off, right? So after that, your hardware kind of runs and hopefully it survives, right? And that's so every 3 years there's kind of a turnover, right? So but your software probably lives a lot longer, right? So it probably lives like 10, 20. Your data may live 30 or 50 years, right? That's another thing. So there's this stack of software technological or data that needs to be maintained or anyway, but you need to think long term. So eventually you need to do that shift. If you put it into a cloud service, yeah, kind of done, right? So because hardware upgrade is not something you actively deal with, at least you shouldn't, because at that stage it's become totally software, right? So you're dealing with the legacy aspect. So it's a very good point. You want to expand?
Also, hardware is expensive, and it takes a long time to get the hardware you need. You can't really, as far as I've come to understand it, you can't really order 20 new machines and have it the next Monday.
That's right.
If you have, like, we're in an age where everything's a meme. If you have a popular service like a game or something like PlayerUnknown's Battlegrounds, they could not possibly have expected the popularity they had during the first few weeks of launch.
Yeah.
And if they had set up a certain amount of machines to serve all these physical machines, they couldn't possibly order enough machines to serve all the traffic that they experienced after a ridiculously short amount of time.
Yeah. Yeah, it's a very good point. So scalability, right? So the adaptability to quick changes, right? So one very good point. The other aspect is like seasonal cycles, right? So for example, you run a simple as a web shop or whatever else around Christmas time or just before that. Surprise, surprise, your traffic goes up like hell, and in January it's flattening out again, right? So and then you wait half a year or a year until it's actually happening again. So you're buying hardware that you may actually not just not need, right? It's a lot of idling going on there. And that's precisely what IaaS services can afford to do, because they basically balance the demand, right? So if you don't need as much, someone else will. They're running the same data center, meaning Amazon achieves a high average level of load on their servers, which means they can easily invest in new hardware because they can predict that they will have the same load in the next year, whereas you can't, right? Because next year may actually be bust. In particular, talking about games, it's a lot more fluctuating there anyway, right? So because you're more in for the short haul, at least by default, but you never know how your demands grow or not, right? So cool. So all good points. In fact, really good points. I appreciate that you're also focused and deeply reflective. But I just want to make it simple. Well, the market. So this is a market chart that just highlights the development in terms of what the market expectations will be in terms of revenue in those different for those different categories: software as a service, IaaS, and PaaS. And the way it stands right now, at least that seems to be the current progression, is that it's clearly, of course, SaaS will lead the game because that's where the consumers are, right? So the everyday user, they will stick to something like G Suite, Office 365, and so on. But if you look as a follow-up here, it's actually IaaS that's taking the lead in the long run. So PaaS will actually flatten out. This I guess, the flexibility of changing both between IaaS vendors as well as running your entire infrastructure, and the costs coming down eventually because there's more players in the field, drive this momentum. And of course the legacy aspect. Actually, a considerable amount of cloud traffic is consumed by services that have previously simply been run locally, and porting those to Heroku is usually expensive because it means coding, right? So, but if it's just about deployment, then it's reasonably cheap. So I think for you as a developer or as developers, whether you are in games or application developments or go down the DevOps route or whatever else, I think it's a good investment to be aware of what IaaS is, how it's done, and what the principles are. Because once you figure those out, they kind of don't really, well, they change, but they probably won't change too much either. I guess even that the investment in learning about Amazon or OpenStack is maybe a more worthwhile one than just buying too much into a particular PaaS platform, right? So as a developer, because you don't know if this is around in 5 years, but for those bigger players, you can be pretty sure, and there's only quite few of them, that they will be around for some time. So on practical grounds, it's probably worthwhile that we know about infrastructure as a service. So infrastructure as a service. Of course, I think we touched most of those aspects already, right? So key advantage on demand scaling. So if you have more load, you can do it. You have fine grid control. Basically on your terminal, you can control the entire data center, bring it down, change load balancing, remove services, and so on. And then you have all those different management facilities here. So both, and it comes back to the initial schema that I showed you. We talked about processing, storage, and networking as the key characteristics of IaaS over PaaS. And that's precisely what you control here, right? So you deal with VMs or container services, large files, dealing with backup, unfortunately, as well, structured and unstructured data. So it's also a good, strong feature that is there. Of course, networking and the overall management of it. So, and as I mentioned before, in all those vendor-specific solutions, specifically Amazon and so on, there's a lot of PaaS elements as well. So it's about it's about you kind of figuring out, okay, when am I using something that affords some sort of vendor lock-in? When am I actually generic enough so I can flexibly change between those? Because what they try to do is to bind the additional products as well. So you're kind of locked into Amazon, even you thought you're kind of flexible and can easily shift to someone else as well. So that's something you'll probably see in an overview of AWS in a week or two or so. So the person left to you there. So you mentioned precisely another aspect. So when do you go public, private, or hybrid cloud? Because those are terms that are used as well, usually in association with those IaaS service, because they are the only ones providing you that situation. If you run, for example, something on Heroku, yeah, you're kind of in a public sphere, right? Because it's shared between different users, and they are even unknown to you. And usually characteristics you pay per use, unless you're on the free tier. But if you use it in a production environment, you need to scale up. The free tier is simply not enough in none of the solutions if you actually have some traffic. And then of course we have the private cloud solutions. That is, the obvious thing. You kind of run the hardware and the cloud. So it's a bit, you definitely need to have some sort of substantial organizational backing and the necessary funds to pull that off. But there may be needs or reasons to do that, right? So if you, for example, have multiple subsidiaries in your organization and you want to still keep that high level of privacy, as you mentioned, because that's effectively what you get by it, by running everything yourself. But having the flexibility of some sort of growth, then this is an option. But of course, it's a bit more of a planned growth in a sense that you kind of still need to buy the hardware for it, right? So it's not just you can scale up and do it ad hoc. You still need to wait for 1 or 2 weeks for your 20 servers to arrive. Yep.
One advantage to having a private cloud would be, privacy as that, and also if you, my example was that if you don't know if you need the hardware at all. If you are big enough and you're able to plan ahead enough, you know that you need the hardware either way, but sometimes you need the hardware to do different things. Mm-hmm. So this is where with the private cloud, you generally just have a uniform clump of hardware. You don't really need to specify RAM or storage or CPUs or whatever. You just buy what you need and just connect it all together. And so if around Christmas you need more processing, you can just use one of the redundant servers you have to, for example, backup or just general redundancy.
Yeah.
You can throw them into the mix and just scale up as you need it.
Yeah.
So that would be an advantage.
Yep. That's a good point. So you're talking about abstraction, right? You're abstracting software from hardware, right? So it doesn't really matter what your current, cycle is actually running on, which particular machine it's running on, as long as you have a virtual computer that ties into the underlying hardware, right? So it's kind of this economies of scale in a way that you, by using the idling time of all your different machines effectively, you can have less aggregate hardware. But if you really need the punch, you have it handy at your avail, right? So you have the full, multiple 100 gigabytes of RAM, for a particular instance if you need it suddenly. So that's a very good point. But you need to kind of be a sufficiently large club to actually do that, right? So to have that value really in there. Because one of the aspects in terms of virtualization is, of course, there's also an inefficiency there. Every time you have abstraction, it is costs, right? Because you need to have some sort of intermediary execution or operation that is translated to the actual operating specific system calls, operating system specific system calls, and it costs cycles. So it costs time. So it's not necessarily super efficient, but the flexibility is the key factor there, right? So. And of course, then there's the hybrid approach where you want to do all the scalability stuff outside and want to do all the privacy stuff basically inside, right? So if you want to split that up somehow, that's one way of doing this. So, for example, a good use case for a hybrid, what's a good use case for organization, the hybrid cloud for practical examples?
In-house storage, sensitive data you would want to have on your own.
Yep.
Not on a server in Ireland, for example.
Yeah.
But the rest of the computing doesn't really matter where it's done.
Yeah, exactly, right? So one of the ideas is if you do it hybrid is one, if you deal with the bigger vendors, they're usually regionally widely distributed. And the advantage there is that you can, for example, do the execution close to where you actually need it, right? So in the customer case, it's close to the actual customer, so it has a low latency, fast response in the web browser, especially if you're globally operating. Whereas your business operations are probably more concentrated and focused. It makes more sense to keep the processing power there, not to speak only of that, but also, of course, privacy, right? So it's like, business-centric versus customer-facing is kind of a bit of a aspect. But you see, if you think about those aspects, that's not something a sysadmin can solve anymore. That's something that you as a programmer need to think about. So that's where the boundaries are really very blurry. If you develop for such a system, it's not just a matter of deploying it differently, it's a matter of structuring the entire system differently. And that needs to be considered very early in the software development process, right? So you can't just reshuffle that afterwards, because most likely you end up in more trouble than you would want to be in. Okay, so talking about IaaS services, which ones are the biggest IaaS services, do you think? Major vendors. One I named like 10 times, possibly. So Amazon, cool. That was good. Yeah, someone was in class. That's good. OpenStack, yeah, it's one solution. Yeah, but let's think. That's more on the private cloud side. We look at this. Sorry.
DigitalOcean.
Ah, yeah, DigitalOcean. Yeah, that's right. Yep. Okay, who else?
Azure.
Yep.
Azure.
Cool. Anyone else? Cool. Anyway, yeah, so good ones. DigitalOcean is something that I should have thought about. So one of the what I consider the more big ones are those three ones here, right? So we have, of course, AWS, Azure, and Google Cloud Platform. And those years are the years when they launched, basically. So AWS is by far the oldest one, and then Microsoft follows up, and Google as well. And they're reasonably, why I'm putting up those ones is that they're all reasonably widely distributed. So when we're talking in terms of wide distribution, there's the idea of having some sort of regions or zones. Because this basically reflects the data centers that are concentrated, for example, in Scandinavia, in Europe, in Northern America, Southern America, and so on. And within those data centers, or between those data centers, it affords fast replication of data, for example, for backup purposes, whereas those are oftentimes disconnected from other zones to prevent, a takedown of the entire system, right? So there's an element of redundancy and isolation as well. So it's kind of a varying set of aspects that are available and provided by those ones. So and they're continuously expanding. So if you look at those the respective websites, they give you a good overview of what they provide. I can just see if I can bring up the Amazon, an overview of the Amazon infrastructure as it is right now. So that's just to get a feel, okay, what the global infrastructure is and what their plans are. So for example, they're planning something in Scandinavia. Probably it ends up being in Denmark because it's still closely connected to the continent, but has a fast internet connectivity. So it's it's kind of a trade-off. Norway is candidate as well because the power is cheap. But yeah, so those are the usual kind of focal points, of course, of their investment. So it's worthwhile having an eye on it when you're planning your deployment. Note though, that's all the costs. Oh, sorry, that many of those zones have different pricing levels because it's varying cost of operating data centers there, but also the varying popularity. For example, data centers in US on I think the northwest coast are not too expensive, whereas in some other areas they are a bit more pricey because there's more load on those. So it's something to bear in mind as well if you deploy there. Anyway, so without going into much feature comparison, that is of course an option, but it's so fast moving that it's probably not too worthwhile exploring that in greater depth. I would like you guys to rather think about the market distributions of all those three ones. So if we think about all the cloud services that are out there right now, and of course we need to motivate what you learn, what do you think, what's their market share actively currently in the IaaS market? Amazon, Microsoft and Google. There are other ones like DigitalOcean, of course, but from those major ones.
I believe AWS is the biggest.
Yeah.
Then it comes Azure, and then Google Cloud.
Okay. Any numbers in mind?
No, I can't tell you.
Yeah.
I think maybe AWS would have more than 50%.
Yeah. Okay.
But I'm not sure about the others.
Yeah.
I think Azure is bigger than Google Cloud.
Okay. Cool.
Based entirely on the fact that I completely forgot about Google Cloud.
That's okay. Is there another aspect that could motivate why Azure is probably bigger than Google Cloud?
I think it's more known. I think Azure is more known, and it's part of a company that's been more geared towards administration for longer than Google has.
Valid point. Yeah.
A lot of companies are already customers from Microsoft, and I think, oh, you have infrastructure now. Cool, let's do that.
Yeah. So it's another thing. Yeah. Any other guesses? All right, I think you set the lead and the pace. Yeah, so actually about right. The numbers, of course, varying. It may not be legible, but the idea is that here I pulled this very recently. So it's about 40% is covered by AWS. So they really have the biggest market share, nearly 30% by Azure. So not far behind, actually Microsoft, you're perfectly right. And Google Cloud sits at pitiful 3%. So it's actually not too popular as of now. One would, I think your guess was absolutely right. But you see there's a lot of distribution still amongst others. About 20% is actually distributed in the space, so very fragmented. DigitalOcean being one of them, most certainly, and various other providers that Arno mentioned. My suspicion regarding Azure being so high is not only, of course, that you have this pull effect from existing customers, it is the fact that they actually have mostly industrial customers, right? Pretty much any big organization is with Azure, with Microsoft, like, having Active Directory and the Microsoft network and, Workstation, the operating system, not to say the least. But also, they are running their own SaaS stuff themselves, right? If you think about Office 365, they're probably not running it on Amazon, right? Yeah. So that is a kind of another possible driver for that. Or even the modern Active Directory services are actually run in the cloud as well, right? No longer locally as well. So yeah, so AWS clearly biggest player. That's one of the reasons why you kind of should have a look at it. We have one issue with respect to having you use it because There's still an issue if you make an account with AWS, you kind of need to put a credit card there, and that's not something we can ask of you. So we need to kind of find a way to expose you, yet not impose it on you. So that's something we need to have a look. So yeah, well, trends. Data center is going down, public cloud is going up. So that's the essence we get out of those charts here. I just wanted to say the classical data center concept where something is hosted in a dedicated data center associated with an organization or the like is probably fading over time unless you do big number crunching when you would use one of those top 500 clusters, or not possibly. But the idea using a public cloud makes much more sense. You have everything at a high level of flexibility, storage, networking, and processing power, of course. So that's the thing idea. Cool. Some challenges I want to highlight in terms of IaaS, because again, you need to be aware of this. Even though you're a bit more flexible in terms of not having a vendor buy-in or buy-in as you have, for example, with Heroku and the like, one of the challenges still there that there is a level of vendor lock-in, because if you're interacting with the APIs, and ultimately cloud programming or cloud computing is strongly about really programming against AIs, you still have a vendor lock-in. So even if you're instantiating the engine on AWS, you're kind of using their API to get your stuff done. So there's no open standards yet that have really are shared amongst multiple vendors. There's a lot of de facto standards. For example, the way AWS does it has been adopted even by OpenStack in some ways. So they kind of borrowed the API to ensure that people that actually have worked with it are more comfortable in another solution. But it's not a shared initiative to do that. And the other aspects are, of course, legal restrictions. So sorry, please, you have some comment.
Yeah, I'm sorry for having so many comments.
No, that's very helpful.
I was actually thinking about that earlier with the APIs being what they are. And yes, if you have a reasonably large service, you will have thousands upon thousands of code just in scripts. But still, that would be, I think, easier and cheaper than having to redevelop the entire software that you're servicing.
Yeah. So that's exactly the point, right? So the code you would develop here is dedicated to managing the infrastructure as opposed to being your software service itself, right? Which it would mean in Heroku, for example, that you need to change the structure of your modules or adapt to a different version of the programming language and things like this. That's right. So it's kind of a twofold sort. Yeah, you have those sysadmin kind of scripty development, and then the actual development in its own right. But I think we will see a flattening of the standardization in a way that there will be a lot of de facto standards that will be coming out, and there will probably be like intermediate APIs that will map across different services to allow easy migration. I think that something like this will be happening, or will be yet another software as a service in the long run that attaches to all those big vendors. Something to bear in mind for you guys, even though you're a technologist, I know, but you still need to think about this. Sometimes there are legal limits or restrictions as to what you can do. Certain countries, for example, don't allow you to process organizational data outside of their national boundaries, outside of their territory. So in this case, if you, for example, do a regional pick in AWS, you kind of need to pick it from the right region to comply with legal restrictions, not so much thinking about performance, for example, or your closeness to the customer, but sometimes there are certain limitations of doing that, right? So I think there was so there are issues like that, for example, that particular sensitive data needs to stay within the territorial boundaries. It's traditional in a way, and cloud computing challenges it, of course, intuitively, but here's what you guys need to bear in mind to some extent. So that's one of the thing as well. But also, of course, strategy. And how far do you want to invest into actively developing your own infrastructure or just using other people's solutions? So there's a bit of a tension there as well in how far, what your actual business model is in your company. Perhaps you're actually interacting on the infrastructure level, so then it's not necessarily clever to use a hosting solution like that. Okay, I'll give you a bit of a break, and then we look at OpenStack, and I'll let you play with OpenStack a bit, because I want you guys to get your hands dirty and actually, see it actually works. So I suggest we meet here in 15 past. That gives you 7 minutes of coffee break, and you guys need it. And anyone who fell asleep, just wake them up to remind them we have 7 minutes of break.